Okay, this problem is involving consecutive integers. Consecutive integers is a very specific type of problem. Well, you know what? All of these are. All of these are very unique kinds of word problems that require different strategies. So for this one, it was basically kind of understanding the words and making sure you knew what you're doing. And this one is you have to think about consecutive integers. And once you know about them, typically you can kind of remember it, I'm hoping. So let's, for example, if they use the word consecutive, consecutive means next, like next, 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 next. If you sit in a row, you are consecutive students, okay? Consecutive integers. So, for example, if I have, let's start with any integer. Name any integer. Let's say -3, -2. That's the next one. The next consecutive integer is like this. Okay, you just keep counting. Okay, the question is, how would you represent this as a variable? Well, let's say I wanted to represent an unknown integer. I would use n. N is the first integer. What would the next integer be in terms of n? In other words, if this little guy's n, how would I get to there? Okay, I would have to add 1. And to get to there, I would have to add another one, right? So like -3 plus 1 is -2. -2 plus 1 is -1. -1 plus 1, in other words, every number differs by 1. So the first number is n. The second one is n plus 1. That's the second. What's the third? N plus 2. To get from n over here, 1, 2, 3, to get to the third, you got to add 2. So it's n plus 2 is the third, and it just goes on. N plus 3 would be the fourth. Okay? So that's consecutive integers. Well, this one doesn't say consecutive. It says 3 consecutive even integers. So let's talk about even integers. Even integers. Okay. Even integers. Well, let's say you pick an even number, 2. What's the next one? 4, 6, 8. Who do we appreciate? Okay, 2, 4, 6, 8, 10, 12. These differ by how many? 2. To get from one to the next, you have to add 2. So the first number for even integers is n. Okay. What is the second number? N plus 2. What's the third number? N plus 4, because it's n plus 2 plus 2. That's how we get even integers. Now, here's the not tricky one. It's not tricky at all. The kids screw up on it more than any other thing. No matter how many times you tell them, I don't know why. Odd integers. You ready? Integers. Ready? Name an odd number. 5, 7, 9, 11, 13. How far do you have to go to get from 5 to 7? 2, guys. Not 1, not 1. 2. So guess what? The first number is n. What's the second number going to be? N plus 2. It's the same. Odd and even is the same. I know it looks wrong because these are even numbers, but I promise you it's not wrong. It will work out. If they say 3 consecutive odd integers, use these. If they say 2, use these. Even and odd, samey same. Okay? So I've added an extra page to do this problem. So we're going to go here. Okay. And it said 3, well, let me help. 3 consecutive even have a sum. That's an important word. Means addition of 42. So 3 consecutive. So it's going to be n plus, what's the next number? N plus 2 plus, because that's the sum, n plus 4 equals 42. And then it's a pretty simple problem. All you have to do is combine like terms and then solve it. So subtract 6 from both sides. If I don't show work, I talk out loud. Minus 6 is 36. Divide by 3 and you get 12. That means the first number is 12. Well, what's the second number? What did we say it was? N plus 2. Second number is going to be 14. What's the third number? You could say 14 plus 2, or you can say 12 plus 4. N is 12, 16. So the only thing you need to do is check it. Is 12 plus 14 plus 16 equal to 42? Well, 6 plus 4 is 10, plus 2 is 2, carry the 1. Check, it works. That's how you do consecutive integers. Pay real close attention to the wording. But remember, odd and even are the same. Okay, this is a mixture problem. Mixture problems are typically problems where they say, a lot of times they do have a dollar amount. It could be like nuts, this kind of nuts and that kind of nuts, or this kind of raisins or mix. And, they always have some kind of mix. A lot of times it's food, by the way. I'm not sure what's up with that. But it's usually that. And so you have to take a look at what they're talking about. So I'll give you a moment to read this problem. All right. So the first time through, whenever I read it, I'm basically just saying, what the crap is this thing talking about? I mean, like, honestly, you don't absorb it all. So what are we talking about? We're talking about coffee. Okay, she makes a blend. She mixes it. She mixes type A. This is what I got from this problem, reading it the first time. She mixes type A and type B, and she gets a blend. Okay, I got that. All right. Then you know that she uses a certain amount of money per pound for A, a certain amount of money per pound for B. And then she says she used twice as many pounds of type B as type A. We'll figure out what that means in a second. For a total cost of this, okay? So how many pounds of type A of coffee were used? Okay, so here is our question. How many pounds? The question is almost 99.9% the variable that you're going to use. So I am going to say, let capital A equal the number of pounds of type A coffee. Okay? All right. So we have A is the number of pounds of coffee, okay, of type A. Then we have type B, but we can't use the letter B yet, guys, and it sucks. Because when you can use 2 letters and you have 2 equations, it makes life so much easier. But we don't do that, so we can't use B. So we have to define B in terms of A. And that's where this little piece gets really important right here. It says twice as many pounds of type B as A. So when it does stuff like that, sometimes I pretend that I'm over here. I'm in the store, okay? And I'm making this blend, okay? If I use A pounds of coffee and I use twice as many pounds of B, okay, so I'm going to mix A and B. What is B equal to? Twice as many pounds of type B coffee as A. Means that if I used 5, just this is an example, this is for me to help understand it, I would use 10 for B, right? Okay, so instead of B, I'm going to write twice A. That is B. B equals 2A. We have now defined B in terms of A. That's important because here we go with our equation. What equation can we write? The total is a money, so we need to talk about money. okay? Type A is going to take $5.95, okay, per pound times the number of pound, plus type B is $4.10 per pound. Now, what is B? We can't put B. I could put B, and then look what happens. This is the problem. This is why you can't put B. I have one equation. I can't have one equation and two variables. I can't solve for one variable. So instead, I have to come back here, and I have to not use the B. I erase the B, and instead of B, I put what I figured out, B to B, which is right here. It's twice A. That's probably the hardest step in this thing. All right, so I'll just continue in red. So we get 595A plus, now you need to multiply these two. $4.10 times 2 is $8.20. A equals 297.15. Then you add these together and you will get, we know we're going to get A. 0 plus 5 is 5. 2 plus 9 is 11. Carry the 1. 8 plus 6 is 14. 15A equals 297.15. And now you need to divide both sides by 14.15. Please go ahead and use your calculator. You know you need to. 297, what is it again here? 297.15 divided by 14.15. Okay, so I'm going to go to my calculator and do 297.15 divided by 14.15. Wait, did I do that right? 297.15 divided by 14.15. Okay, yes. What is it? 21, and that's your answer. So A, give me my pen. Okay, so A is equal to 21. I'm sorry, that looks really bad down there. That's terrible. Don't do that. Don't do that, Miss Baca. That's terrible form. Okay, so I'm just going to grab a different color because why not? Here we go. Equals 21. And so it's 21 pounds of A. Okay, and that's the answer to that. It's really helpful when you use the variable that you want there. Use the variable as the unknown. Okay, solving a word problem involving rates and time conversion. Typically with conversion, this one actually is kind of an easy problem, but typically with conversion, you can set up a proportion usually if it's easy. If it's easy, you could do a proportion. If it's bigger than a proportion, you can use stoichiometry like you did. I don't know how to spell stoichiometry. I'm not sure if it's an E or a Y. Okay, proportion, you can use stoichiometry, or you can use your brain. Like some of you guys are going to be able to do this problem no problem. And you'll be like, Ms. Baca, why are you making it so hard? It's because sometimes it's not that easy for everybody else. Okay, so if you're just like little genius on this, you go ahead, you do you. It says a light bulb consumes 36 watt hours per day. So usually you can write that down as this is a ratio, you guys. When you have ratios, by the way, you often have proportions. Okay, 36 watt hours per day. It says how long, okay, how long does it take to consume 18,900 watt hours? See how watt hours is over day? And this is one day. We're looking for X days because we don't know how many days it's going to take to use 18,900. Now, some of you might just go, oh, well, don't you just take 18,900 and divide it by 3,600? Yeah, that's what you do. But I'm setting up as a proportion for those of us who don't always get it. That's watt hours, by the way. See, watt hours days, watt hours days. Now you can cross multiply and you get 3,600 times X equals 18,900. Now you just need to solve for X by dividing by 3,600. And you get X is equal to 1890 divided by 3,600. Let's go to the calculator. 18,900 divided by what? Why can't I remember two numbers in a row? 3,600. Seriously. brain dead, 5.25. All right, so that means that it would take 5.25 days. Now, if they did want you to change 0.25 days into, say, hours, what is a quarter of a day? There's 24 hours in a day, so you'd multiply that. It would be 5 days, 6 hours. Because a quarter of a day is 6 hours. All right, that's the proportion.